In today's lesson, we will learn about set, types of set, ways to write set, operations on set, and Venn diagram. Now, first we will see what are sets. So, a collection of well-defined and distinct objects is called a set. And these objects, which form parts of set, are known as elements. There is a need to split this definition into different portions. So first we will understand the meaning of the word well-defined and distinct with the help of some examples. Now the word distinct means we cannot write any element more than once. We will understand the word distinct more precisely in the examples. Now what is meant by well-defined? So here we take two examples. The first one is a good teacher, and the second one is intelligent student. So here we can see that two examples. A good teacher. In the case of good teacher, can we make a set? Let's think. The answer is no, because your idea of a good teacher may be different from mine. So this is not a set. Now move to the next example. Intelligent student. Can we make a set in this case? Think again. No, the answer is no, because the word intelligent is not well defined in this case. So from these two examples, we conclude that all the elements in a set should be distinct and well defined. Before moving forward to the ways to write a set, we will first understand the statement. All the elements in a set should be distinct and well defined through an example. So let's try to list down the cricket playing nations: Pakistan, England, India, Brazil, and so on. In this case, each cricket playing nation is a member, and every cricket playing nation is well defined because each cricket playing team is a member or an element of the set we are considering now. And every element is distinct because every element occurs only once. Now we will define the different ways in which a set can be written mathematically. These are the two methods: a listing method or form and set builder form. From our discussed example, we can interpret the meaning of well-defined as
an element
belongs to the set or not. Now we are going to discuss the listing method. We will start with the first three natural numbers. So here we write down the curly brackets. These curly brackets are used to mark the start and end of the set. And the natural numbers 1, 2, and 3, these are the elements inside the curly brackets. And the last thing, commas. These commas are used to separate the elements. So this is a mathematical representation of a set, and this is a much simpler method to write down the set in a mathematical form. A question comes to our mind: why we need another method to write down a set in a mathematical terms, since we have a much simpler method to write down the set in mathematical terms. That method was a listing method, but soon we will see that this form is a very powerful way to write down a set in mathematical terms. So now we will discuss each and every component of this written set. What is x here? X is a variable and we call it x in our case, but you can you can give it or assign it any other name according to your choice. And what is this? This colon means such that. And this means x less than 4 and x belongs to natural numbers. In this comma, separate these two conditions. And this comma means and. Now we will discuss these two conditions in detail. The first condition says that x is less than 4. We have this condition since we have been asked for just first three natural numbers. But this condition is not enough, as less than 4 can mean a decimal number or negative number less than 4, and that's precisely why we have the second condition. So it will make more sense if we read it as a whole thing aloud. Read it as set of all x such that x is less than 4 and x belongs to natural numbers. So this is a set builder method to write down a set in a powerful way in mathematical terms. Now we will see what is Venn diagram with the help of an example. So now we try to draw a circle and try to write down the first three natural numbers inside it. So this is called a Venn diagram. In Venn diagram, we just need to draw a circle and write down the elements inside it. You can see here that we have two sets, I and F, having the Venn diagram. The set I is a set of people who like ice cream, and the set F is the set of people who like fruits. What will you do if you have been asked to find out the set of people who like ice cream or fruit, or at least one of these both? The answer is you have to find out I union F. It means I or F or both. Now you can see that A, B, and C. A and B already like ice cream, but D has not been included yet, so it had to be included in the set, and so does G. So this is the set of people who like ice cream or fruits, or at least both of these. Now what will you do if you have been asked to find out the set of people who like ice cream and fruits both? Let's think. So here we have to find out I intersection F. It means both I and F. So there is only two people, A and B, which like both ice cream and fruits. So here we have A and B. And this is the set of people who like ice cream and fruits both. Now we will see how these Venn diagrams help us to find out the union and intersection of the sets I and F. So let's move the set F towards left in such a way that the set I and F overlap with each other. So now we can see here that these both sets are called overlapping set, and the region they share, the common region both the sets are sharing in the Venn diagram, is called the overlapping region. Both the sets have overlapping region because there are some elements in common. Now we will see how these Venn diagrams help us to find out the union and intersection of the sets I and F. So let's move the set F towards left in such a way that the set I and F overlap with each other. So here we have an overlapping region. The set I and F has overlapping region because there are few elements which are common to both of them. So from this Venn diagram, you can clearly see the representation of all the elements here. So from Venn diagram, it's much simpler to write down the union. You just had to write down all the elements you can see here. And for I union, I intersection, you just have to write down the elements which you can see in the overlapping region. So what you have interpreted from this Venn diagram, we have concluded that if you have drawn the Venn diagram correctly, then you can easily find out the union and intersection of the given sets. Now we will play a simple game of coloring and guess. We will color a region and guess a set. What about the region colored in yellow tells us? This region colored in yellow only includes the students who play football and includes nothing from the set T or set B. Similarly, the region colored in green only includes the students who play tennis and do not include anything from the sets F or B. Last but not the least, the region colored in red only includes the student who play basketball and nothing includes anything from the sets F or D. Now the next question is very tricky one. Does this pink region shows F intersection B? The answer is no. Don't worry if you think this is the answer. There are many go wrong in the three sets Venn diagram. This region highlighted in black is F intersection B, but this pink marked region is F intersection B minus D, because it has been observed that it does not include anything from set D. Now you should probably get the next region correct. This region colored in purple includes student common to football and tennis, but it excludes the basketball. So it will be F intersection D minus B. And now what about this orange region? It will be D intersection B minus F. Now the most important region colored in black, where all the sets F, D and B meet or intersect or overlap. So this region will be F intersection B intersection D. So these are the regions you should know well. These ones were a bit tricky, but there are a few more questions to know if you understand the regions well. What this red region tells? This red region is F intersection B. What about this region colored in dark blue? This shows F intersection B, and it also includes the students who play all the three sports. And this yellow region is D intersection B. Once you learn to recognize the regions, you will probably love to solve the Venn diagram questions. What is a subset? Consider you have three flavors of ice cream and you have to choose one flavor at a time. So you have three flavors: mango, vanilla, and chocolate. Denote these three flavors with small alphabets, say M, V, and C. So you can choose any one kind of ice cream at a time, either mango, vanilla, or chocolate. What would be the possibilities if you have feeling to have two flavors at a time? So you may choose mango and chocolate together, or you may want vanilla and chocolate together. Is there any other possibility? Yes. Or you may want mango and vanilla together. Is there any other possibility if you have filling all the three flavors together? Yes. But there is one possibility. There's only one possibility in this case, which is the main set: mango, vanilla, and chocolate. So you have a high fever, and doctor has advised you to against having any ice cream. So in this case, you have to choose none of them. So here we have the empty set. All these sets on the right are the part of the main sets. So from this example, we can say that subset is a part of the main set. We take another example to understand the concept of subset very well. So consider two sets P and Q. So P is equals to 1, 2, 3, 4, and
Q is equals to 1, 2, 3, 4, 5, and 6.
We can see that every element of P, every element is also an element of set Q. So in mathematical terms, we can say this statement in such a way by using a symbol, U slipping on a line. This is a symbol for a subset. But we can see another new thing or another different thing in these two sets. There are two elements 5 and 6 in a set Q which are not present in set P. So how could we explain this scenario in mathematics? So in mathematical terms, we can say that P is a proper subset of Q, because every element of P is also an element of Q. But for proper subset, there is at least one element in Q which is not present in P. Then we call it as P is a proper subset of Q. Now we understand this with another example. Consider another two sets, A equals to 1, 2, 3 and B equals to 1, 3, 2. These two sets are same because these two sets having same number of elements, and every element of A is also an element of B. So we can call that A is a subset of B. But can we also say that A is a proper subset of B? Let's think. No, this is not a proper subset. Just because there is no element or any extra element present in B which is not a part of A. So A is not a proper subset of B. What is finite set?
A set having a finite number of elements is called a finite set.
Say we have a set of color of rainbows: violet, blue, green, indigo, orange, yellow, and red. 7 days of a week is another example of a finite set. What is infinite set? A set containing infinite number of elements called infinite set. Set of natural numbers is an example of infinite set because the elements in the natural numbers set are infinite.
What is a universal set? We will understand it through an example. Consider we have three sets P, Q, and R. P is a set of all students such that X is a student of class 6A. P is a set of all the students of class 6B. And R is a set of all the students in a class 6C. The universal set in this case is just like X is a set of students of class 6. Universal set is denoted by U. As we can see, P, Q, and R are all these three sets are the part of the main set U. So what is the main thing or the main feature any universal set should contain? Universal set should be suitable. If we can say in our example, use a set of all the students in your school or use the set of all the students in the world. But it is more suitable to say that X is a set of all the students of class 6. So here we have just like P, Q, and R. All are the parts of universal set U. We can write it mathematically. P is a proper subset of U. Q is also a proper subset of U. And R is also a proper subset of U. The next topic that we are going to discuss is operations on set. What is an advantage of just drawing a circle and writing elements inside it? It helps us to find out the union of sets and intersection of sets. The set A and B are given in the question. So the set A is equals to 1, 2, 3, 4, and 7, and B is equals to 2, 4, 8, and 10. And now we have to list down all the elements of A intersection B in the set notation. And what was the definition of intersection of two sets? Intersection of two sets is the set of elements which belongs to both set A and B. So here we have two elements, both sets, 2 and 4. So we can see that 2 and 4 are common to both the sets A and B. We can write down 2 and 4 in the intersection. Now we have to draw a Venn diagram to represent the sets A and B. So here we have just drawn a circle for set A and similarly another circle for set B. And now we just writing down the elements of set A in the first circle and the elements of set B in the second circle. So in the first circle, we will write down 1, 2, 3, and 4. Similarly, in the second circle, we have 2, 4, 8, and 10. Now move the set B to the left in such a way that both the sets A and B overlap with each other. Here we get the overlapping region. This overlapping region help us in which way? It helps us to find out the A intersection B. So this is the beauty of the Venn diagram, that we can easily find out the A intersection B in just a few seconds. So in our case, we can easily see that 2 and 4 are the only elements which are present in the overlapping region. So from this Venn diagram, we can write here that A intersection B is equals to 2 and 4. So now we have two sets, C and D. The set C having the elements blue, green, yellow, orange, red, and pink. And the set D having the elements yellow, pink, and blue. And we have to find out C intersection D. So according to our definition, we have learned, just need to find out the elements which are common to both the sets C and D. So we will just write down here the elements in C intersection D, which are marked by red color. So the C intersection D is equals to yellow, pink, and blue. From this thing, we can also interpret another thing, another fact that we have learned. Here, C intersection D is equals to D, which means D is a subset of C. As we can see that the set D is a part of set C, or mathematically we can say that D is a subset of C. So if we have a case in which one set is a subset of the other set, then we will draw a Venn diagram in such a way that the subset is drawn inside the circle of the main set. Here we have set D having the elements red, green, orange, yellow, pink, and blue, and D having the elements yellow, pink, and blue. And what is the overlapping region in this case? In this case, the overlapping region is the set D inside the circle. This is the overlapping region. Now we have the sets E and F. Set E is equals to P, Q, R, and the set F is equals to S and T. We have to find out the E intersection F in set notation. So as we can see here, there is no such common elements, or there is no such elements present which are common to both the sets E and F. So in this case, E intersection F is an empty set or a null set. So from this we can interpret one thing, and that is as E intersection F is empty set, so F is a subset of E. As E intersection F is equals to null set, so E and F are disjoint sets. There is nothing in common between the sets E and F. Now we have drawn the Venn diagrams for the set E and F, but there is no overlapping region between E and F because the sets E and F are the disjoint sets, so they have no elements. Now we have two sets, the set G having the elements apple, orange, banana, grape, durian, and pear, and the set H having the elements apple, banana, grape, and strawberry. And we have to find out G union H. So according to the definition, we have to find out G union H. G union H is the set of elements which belongs to G or H or both. So we have just marked the elements which should be included in the G union H. And according to the definition of this set, all the elements should be distinct and well defined. So all the elements in the G union H are well defined because all the elements are the fruits, and every element is distinct. It means no element could be written more than once. So we have just write down each and every element only once. There should be no repetition. So hence G union H is equals to apple, orange, banana, grape, durian, pear, and strawberry. Now we have moved the set A to the left in such a way that the sets G and H overlap with each other. Now, how this Venn diagram help us to find out G union H? To find out G union H from the Venn diagram, we just need to write down all the elements that we can see here. So all the elements here are orange, pear, durian, apple, grape, banana, and strawberry. So this is the power of the Venn diagram, which gives us the authority or the power to find out the union in just a few seconds. The Venn diagram represents the sets I and J. So as we can see that I is a subset of J, so we can draw a Venn diagram in such a way that the Venn diagram of set I will be drawn inside the Venn diagram of the set J. So what is the overlapping region in this case? So here we have the overlapping region. Now in part 2, we have to find out all the elements of I union J in the set notation by using the Venn diagram. So by using this Venn diagram, we can easily write down I union J within few seconds. We just need to write all the elements we can see on the screen. So here we have X, V, Z, W, and Y. So this is the advantage of Venn diagram, that we can find the union of two sets within few seconds. The set K is equals to 11, 13, and the set L is equals to 12, 14, 15, 16, 17, 18, and 20. In the first part, we have to draw the Venn diagrams to represent the sets K and L. So in this case, to draw the Venn diagrams for set K and L, we just need to draw two circles and put the elements of set K and L inside them. And these two sets are not overlapping just because they are not sharing any common element. Now, by using the Venn diagram, we have to list down all the elements of the K union L in the set notation. For part 2, we just need to write down all the elements that we can see on the screen in the K union L. So here we have 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So this is the K union L in the set notation that we have find out from the Venn diagram. Now in this question, we will see that M and N are given in the set builder notation. So first we will read these two sets. The set M says M is equals to X such that X is a perfect square such that X is greater than 0 and less than 70. So we have to find out a perfect square, or variable X is a perfect square which should be greater than 0 and less than 70. Okay. And what is the n? N is equals to X such that X is a perfect cube such that X is greater than 0 and less than 70. So our variable X in this case of set N should be a perfect square which lies between 0 and 70. Or in other words, it should be greater than 0 and less than 70. Okay. So our variable in both the cases need to be positive just because X is greater than 0. And our X will not exceed the number 70. It should remain less than 70. Okay. So what is perfect square? A perfect square is a positive integer which is obtained by multiplying integer by itself. So what are the first possible positive integer which gives us perfect square? So this is 1. Now find another one. 2. 2 times 2 gives us 4. 3 times 3 gives us 9. Similarly, 4 times 4 gives us 16. 5 times 5 gives us 25. 6 times 6 is 36. 7 times 7 is 14. And then 8 times 8 is 64. Now move to the set N. So the first perfect cube is 1 into 1 into 1 gives us 1. 2 times 2 times 2 gives us 8. 3 times 3 times 3 times 3 gives us 27. 4 into 4 into 4. If we visualize it, it is just like this. 4 times 4 times 4 gives us 64. So this is the set of all the perfect cube, positive perfect cubes less than 70. Now, in the second part, we have to find out M intersection N. So for M intersection N, we just need to put the elements which are marked with green. So here we have 1 and 64. So M intersection N is 1 and 64. Now in part 3, we have to draw a Venn diagram to represent the set M and M. So we just draw the Venn diagram for the set M and N. And here we have having the elements 1 and 64. The set P is equals to X such that X is a multiple of 8 such that X is greater than 0 and less than equal to 32. And Q is equal to X. X is a multiple of 4 such that X is greater than 0 and less than equal to 32. So in the first part, we have to list all elements of P and Q in the set notation. So for part 1, we have to find out the numbers between 0 and less than equals to 32, which are multiples of 8. So in this case, we just need to remember that table of 8. So 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32. So we are done. Now for Q, we have to find out the multiples of 4 such that X is greater than 0 and less than equals to 32. So we just need to remember the table of 4. So 4 ones are 4 is 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 sixes are 24, 4 sevens are 28, and 4 eights are 32. So here we have write down all the elements of the set P and Q in the set notations. Now in the part 2, we have to find out P intersection Q. So we just mark the common elements. So we just mark the elements which are common to both the sets P and Q. So here we have 8 and 16 and 32. So here we will write down the elements marked in red. So here we have 8, 16 and 32. Now, and here we have another element, sorry. Now in the part 2, we just mark the numbers in red which are common to both the elements P and Q. So here we have 8, 16, 24 and 32. These elements are common to the sets P and Q. We have to draw a Venn diagram to represent the sets P and Q. Now we can see one thing here. The set P is a part of a set Q. It means that all the elements of P are also in set Q. So that's why we can draw a Venn diagram for the sets P and Q in such a way that the Venn diagram of set P lies inside the Venn diagram of the set Q. Now, last but not the least, is P intersection Q is equals to P? We have to explain. So here, part 4, we have to answer the question that P intersection Q is equals to P. Why? The P intersection Q is equals to P, yes, because all the elements of set P are also in set Q. So in the set R, we have two conditions. X should be a positive integer and a factor of 18. So what is meant by factor? All the possible products of any two numbers is called factor, okay? So in the case of 18, 1 times 18 gives us 18. So here we can write down 1 and 18. And we have to find out another possible product.
2 times 9 also gives us 18.
So here we have 2 and 9. Is there any possibility or is there any possible product that gives us 18? So here we have 3 into 6 and it gives us two numbers, 3 and 6. So these are the possible factors of 18. Now we have to find out the set S in a set notation. And for set S, we have two conditions. X should be composite number and it should be between 9 and 18. So what is composite number? A number that has more than two factors is called a composite number. So we have to find out
A number
which has more than two factors. So here we have 10, 12, 14, 15, and 16. Now we will check that 10 is a composite number or not. So 1 times 10 gives us 10. 2 times 5 also gives us 10. So this is a composite number because it has more than two factors. Now in the second part, we have to find out the R intersection S. So we just mark the elements with red, which are common to both these sets. But if we analyze set R and S, there are no such elements which are common to both the sets R and S. So here we have R and S equals to null set. Because R and S do not share any common element. Since R intersection S is an empty set, so it means R and S are disjoint sets. That's why the Venn diagrams of set R and S are drawn in this way. So if we have seen a Venn diagrams of any two sets which has no overlapping regions, so it means those sets are disjoint. The set T has two conditions. X is a multiple of 3 and X is greater than 0 and less than equals to 18. So we will have to find out the multiples of 3. We just need to remind table of 3. So here we have 3 1s are 3, 3 2s are 6, 3 3s are 9, and 3 4s are 12, 3 5s are 15, and 3 6 are 18. So here we have to stop at the number 18 because x is just need to be less than or equal to 8. Now for the set S, we have two conditions. X is a positive integer and a factor of 18. So the set V will be like the factor of 18. So we have discussed in the previous question that what are factors. We just need to remember again that all the possible products of any two numbers are called factors. So 1 times 18 gives us 18. 2 times 9 gives us also 9. 2 times 9 gives us also 18. And 3 times 6 also gives us 18. And these are all the possible factors of 18. Now in the second part, we have to draw the Venn diagram to represent the sets T and V. So we will just draw the Venn diagrams here. So here we have sets V and T. Now first we will mark the common elements with red. So we have 3, 6, 9, and 18. So we will write down here 3, 6, 9, and 18. And here we have 12 and 15. And here we have 1 and 2. Now we can see in the second part that we have a Venn diagram, and the set V and T are the overlapping sets because they have some elements in common, or they are sharing some common elements. And in the part 3, we have to find out the T union. So to find out the T union, we have two methods in front of us. The first method is to just see the set notations of set T and V and write down all the well-defined and distinct elements, or the elements which are belong to T or set V or both. Or we can use the Venn diagram. So we will go with the Venn diagram. If we have a look on the Venn diagram, then we will write down all the elements that we can see in the Venn diagram of the sets V and T. So here we have 1, 2, 3, 6, 9, 12, 15, and 18. So this is how Venn diagrams help us to find out the union of set T and V within few seconds. Now we have to find out the elements of W and X in set notation in the first part. So what is the set W? The set W is equals to X such that X is a multiple of 4 such that X is greater than equal to 1 and less than 16. So we have to apply the definition of multiple. What are multiples of 4? The multiple of 4 are obtained just by multiplying the 4 with the natural numbers one by one. So 4 times 1 gives us 4, and 4 is a multiple of 4. 4 times 2 equals to 8, and 8 is another multiple of 4. Similarly, 4 times 3 is equals to 12, so 12 is another multiple of 4. So here we have infinite number of multiples. But according to our condition, our x should be less than 16 and greater than equal to 1. So we're just choosing the first 3 multiples of 4. So in our case, the set W in the set notation is W is equals to curly bracket 4, 8, 12, curly bracket close. Now in the question, x given in the set builder notation, the set x is equals to x such that x is a positive integer and a factor of 24. So we have to find out the factors of 24 according to our given condition, and x should be greater than 0, or in other words, it will be positive integer. Okay, so what are factor? Factor means all the possible products of two numbers. Okay, so we have to find out the two numbers which gives us 24. So 1 times 24 gives us 24. Similarly, 2 times 12 also gives us 24. 3 times 8 gives us 24, and similarly 4 times 6 also gives us 24. So these are all the factors of 24. Here we have 1, 2, 3, 4, 5, 6, 7, and 8 factors of 24. And we know that the factors of any number are finite. So now we will write down these numbers. Here we have 1, 2, 3, 4, 6, 8, 12, and 24. So now we have also find out the elements of x in set notation. Now we will mark the common elements. 4, 8, and 12 are the elements which are common to both the sets W and X. And W is a part of X, or in other words, W is a subset of X. So the Venn diagram will be look like this. here we have set X, and here we have set W inside somewhere in the set X. So this is the set W. Okay, so the common elements are 4, 8, and 12. And here we have 1, 2, 3, 4, 6. And this is the overlapping region. Since W is a subset of X, so that's why we have drawn a Venn diagram in such a way that the circle of the set W lies inside the circle of the set X. Now in the third part, we have to find out the X union W from the Venn diagram that we have drawn. So from the Venn diagram, we just need to write down all the elements that we can see on the screen. So here we have 1, 2, 3, 4, 6, 8, 12, and 24. And this is equals to X. So hence we have find out W union X. Now in part 4, we can see there is a question. Is W union X is equals to X? We have to explain. So the answer is yes, because all the elements of set W are also in set X. Or in other words, W is a subset of X. So that's why X union W is equals to X. Now we have to list down all the elements of Y and Z in a set notation. So what is set Y? A set Y is such that X is X such that X is a positive integer and a factor of 25. So what will be the elements of Y look like? So the factors of 25, we have to find out all the possible product of two numbers, which gives us 25. So 1 times 25 gives us 25. 5 times 5 also gives us 25. Now we have to write down all the factors in the set Y, and X should be positive integer, so it should be greater than 0. Now we have three multiples, 1, 25, and 5. So 1, 5, and 25 are the elements in the set Y. Now what about set Z? Now we have set Z such that X is a multiple of 6 such that X is less than 25 and greater than 0. So we have to find out the multiples of 6. How would we find out the multiples of 6? So we multiply the natural numbers with 6 one by one, and we will get the multiples of 6. So 6 times 1 gives us 6. 6 times 2 gives us 12. These two are the multiples of 6. Similarly, we will get infinite number of multiples of 6. But we have to stop where there is another condition here. This condition says that X should be a positive integer and less than 25. So we just need the first 4 multiples of 6 as an element of set Z. So set Z will be equals to curly bracket 6, 12, 18, 24, curly bracket close. Since we have find out the elements of Y and Z in set notation, now by using these two sets, we have to draw a Venn diagram to represent the sets Y and Z. So for this, we will draw a circle for set Y and put all the elements of set Y in it. So we have 1, 5, and 25. Now we draw another circle for set Z and write down all the elements of set Z in it. We have 6, 12, 18, and 24. So we can see that these two sets are disjoint because they do not share any common element. Now in part 3, we have to find out Y union Z from the Venn diagram. So we simply write down all the elements that we can see on the screen in the union of the sets Y and Z. So here we have 1, 5, 6, 12, 18, 24, and 25. So hence these are all the elements of Y unions. Now in question 13, it is given that set A, xy is an ordered pair such that xy are the coordinates of the point on the curve y is equals to x squared minus 3x plus 2 such that x and y are integers. And the set B is a set of ordered pair xy such that xy are the coordinates of a point on the line y is equals to 0 such that x and y are integers. So we have to describe A intersection B in the set notation. Now for A intersection B, we have xy such that xy are the coordinates of the points of intersection between the curve y is equals to x squared minus 3x plus 2 and the line y is equals to 0 such that x and y are integers. So in both the sets, x and y are integers. So we have just taken that conditions from both two sets. In other words, this condition is common in both the sets. And now we have to find out the elements which are lies between the intersection of these two sets. So these are the coordinates of the points of intersection between the curve y is equals to x squared minus 3x plus 2 and the line y is equals to 0. So this is our A intersection B. In question, we have given two sets. The set C, and so the set C is the ordered pair such that xy lies on the curve y is equals to x squared plus x plus 2 and D is equals to xy ordered pair such that ordered pair lies
lies on the line y is equals to 3x plus 5. So here we have two curves. Two curves are given here. The first one is y equals to x square plus x plus 2. Call this equation 1. Now we have another y is equals to 3x plus 5. Call this equation 2. Now put equation 1 equal to 2. So here we have x square plus x plus 2 equals to 3x plus 5. And now we have x square plus 2, and that x on the left side will be goes on right hand side and becomes minus x. We have minus x plus 3x, and the plus 5 on the right hand side will become minus 5 when it goes on the left hand side. So now we will solve it. We get x square minus 3, and here we have minus x plus 3x equals to 2x. So now we have x square, and the 2x on the right hand side will become minus 2x when it comes to the left hand side, minus 2x minus 3. So our equation now x squared minus 2x minus 3. So now we get a quadratic equation. So what will we do here to find out the values x or the roots of this equation? So we will write down here the values of a. Here is 1, b here is minus 2, c is minus 3, and now we will use the quadratic formula. So the quadratic formula is x is equals to minus b plus minus under root b square minus 4ac over 2a. Now we just put the values here. Minus b into minus 2 plus minus. The value of b is minus 2, so minus 2 square. The value of a is 1, and the value of c is minus 3, and the value of a is 1. Now by solving the next step, we get x is equals to 2 plus minus under root 4 plus 12 over 2. And after simplifying, we will get 2 plus minus 4 over 2. Now we have x equals to 2 plus 4 divided by 2, and the second value of x is 2 minus 4 divided by 2. Here we have 6 over 2 and minus 2 over 2. And so the first value is x is equals to 3. The second one is x is equals to minus 1. So we get the two values of x. X is equals to 3 and x is equals to minus 1. Now just put these values of x one by one into the equation 2, and we will get the values of y.
Now we have, since x is equals to 3 and x is equals to minus 1.
Now to find out the values of y, first we have to put in equation 2 x is equals to 3. So
We have y is equals to 3 into 3 plus 5. And now we get 3 into 3 gives us 9 plus 5 equals to 14. So the first value is of y is 14.
now to find out the second value of y, we have to put x is equals to minus 1 in equation 2. So put in 2 x is equals to minus 1.
So we have y is equals to 3 into minus 1 plus 5 and minus 3 plus 5. And we get y is equals to 2. Now we have got pairs. We have got two ordered pairs. When x is equals to 3, then y will be equals to 14. And when x is equals to minus 1, then y is equals to 2. So C intersection D will be having two ordered pairs. The one is 3 and 14, and the other one is minus 1 and 2.
So these are the two elements of C intersection D. Since we have two curves, the first curve is y is equals to x minus 5 whole square plus 3, and y is equals to x plus 2 whole square minus 4. If we take any value of x, it means if we take any real number as a value of x and put into these two equations given in the question, then we will get the answer always positive, because both of these equations involving square. So for the first equation, now we will taking the equation of the curve y is equals to x plus 2 whole square minus 4. Now take the value of x is equals to minus 2. So the equation will become y is equals to minus 2 plus 2 whole square minus 4, and this will become 0 square minus 4, and we have the value y is equals to minus 4. Now take x is equals to minus 2 and put this value into the equation y is equals to x minus 5 whole square plus 3. So the equation will become y is equals to minus 2 minus 5 whole square plus 3, and it will give us minus 7 whole square plus 3. Minus 7 whole square gives us 49, and it will come 49 plus 3, and 49 plus 3 is 52. So the value of y is 52. So we have find out the least value of y that we will get is y is equals to -4, and we have get another value y is equals to 52. So from this we can conclude one thing is y is equals to -4 and another value is y is equals to 52. So A union F will be look like y such that y is a real number such that y is always greater than equal to -4. So the least value of y is -4 and either value is always remains greater than -4.